All right, welcome back. We're going to talk a little bit about series in this video. We've been doing sequences. A series is really the same thing. You're doing a sequence, but you're just adding all of the numbers up in the sequence. So let's look at a particular series problem. All right, so we have this scary looking Greek letter right here called sigma. Whenever you see it in math, it just means add them up. That's pretty much it. It's a summation notation. All right, now down at the bottom, you're going to see letters like I or J or K or N. I'm going to use an I. It's your starting number. It's where to start, and the top is your stopping number. And that's inclusive, meaning you start with 1 and use it, and you end with 5 and you use 5. And then here you'll have a rule. So let's say the rule is 3i minus 1. All right. So all you do to do a series is you find the first 5 terms of this series from the rule and add the numbers up. So when I put a 1 in, I think we can do this in our head, right? It's going to be 3 times 1 is 3. And then 3 minus 1 is 2, so 2 plus. Then I put a 2 in. Well, that's going to be 6. And 6 minus 1 is 5. Then I put a 3 in. Well, 3 times 3 is 9. 9 minus 1 is 8. And as you can see, we're just adding 3 every time, aren't we? So the first number is 2, add 3, get 5, add 3, get 8. Add 3 to that, you're going to get 11. Add 3 to that, you're going to get 14, and I stop, because that's the 5th number. And that's where it says to stop right here. When I put a 5 in, 3 times 5 is 15. 15 minus 1 is 14. That's it. So then we just add them up. All right, so, well, what do they add up to? This sequence is, what kind of sequence is it? These numbers 2, 5, 8, 9, what do we call this type of sequence? It's arithmetic, right? Because we're adding the same thing every time. Whenever you have an arithmetic sequence, there is a shortcut. What you can do is you can take the first number and the last number, and if you notice that, it's a 16. And then these two numbers right here, well, they also add to 16. And then this leftover one is half of 16. So we basically have 2.5 16s, don't we? So 2.5 16s would be, adds up to 40. And you could just add them up if you want, but that's the shortcut, and we're going to do more with that later when we talk just about arithmetic sequences and series. All right, try one by yourself here. So here's another. So the sum, let's do a j, just to mix it up. So j equals 1, and we'll just go to 4, and the rule would be about 3 times n minus 1. Okay, so j minus 1, because we're using the letter j. All right, so remember, you find the numbers and then you add them up. Go ahead and give it a shot. All right, so what's the first number? Well, when I put a 1 in, that's 0. And then you multiply by 3 and you get 0. All right, plus. Then you put a 2 in. Well, 2 minus 1 is 1. 1 times 3 is 3. Plus. Then you put a 3 in. Well, 3 minus 1 is 2. 2 times 3 is 6. So you see we're just adding 3, add 3, add 3. So add 3 to that, I'm going to get 9, and I'm done. It's the first number to the 4th number. So again, this is arithmetic, so these two should add up to the same as these two, and they do. 0 plus 9 is 9, 3 plus 6 is 9, so it's twice 9, which is 18. All right, that's all there is. Let's try one that's not arithmetic. So we'll do, this time, notice I'm starting with, I'll do a K. I'm starting with a 0 down here. And I'm going to the 5th number in the rule is 2 to the k power. So find those numbers. Keep in mind, here I started with 1 to 4, so that gave me 4 numbers. How many numbers am I going to have if I start at 0 to 5? Not 5 numbers. So go ahead and find those first 5 numbers and add them up. Or, sorry, not 5 numbers. More than 5 numbers and add them up. Okay, so what do we get? Well, we start with 0. We put 2 to the 0 plus, then 1, 2 to the 1 plus, 2 to the 2 plus, 2 to the 3 plus, 2 to the 4 plus, 2 to the 5. We stop at 5. All right, so how many terms do we get? 1, 2, 3, 4, 5, 6 add-ins, right? These are called add-ins since we're adding them up. So what do these equal? Well, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, so plus 8, 2 to the 4 is 16, and 2 to the 5 is 32. This is not arithmetic, so that little trick we used earlier by adding these together and these together is not going to work. You just have to add them up. So let's see what we get when we add them up. Let's get this up. So 2, 1 plus 2 plus 4 plus 8 plus 16 plus 32 is 63. So the answer is 63. All right. Let's do another one. Find these sum. I'll start with k equal 1 this time. We'll go to 5 again. And let's make it interesting this time. We'll do -2 raised to the k. All right, go ahead and add those up, see what you get. All right, so here's what we get. -2 to the 1 plus -2 to the 2 plus -2 to the 3 plus -2 to the 4 plus -2 to the 5. All right, what is -2 to the 1? -2. -2 squared, +4. Be careful, make sure you put your negative in parentheses. Parentheses, -2 raised to the second power is +4, not negative. All right, this one has an odd exponent, so it's going to be -8. This one has an even exponent, so it's going to be +16. And then -32. All right, let's go ahead and add these up, see what we get. So -2 plus 4 plus -8 plus 16 plus -32 is -22. Pretty easy, right? All right. Let's do another one, a little more complicated. Let's do the sum for n equals 2 to 6 for how about 8 times 1/2 to the n power. All right, so I'm using the letter n this time. Okay, so see if you can figure that one out. All right, let's see what we get. We got 8 times 1/2 to the 2, because we start with 2, plus 8 times 1/2 to the 3, plus 8 times 1/2 to the 4, plus 8 times 1/2 to the 5, plus 8 times 1/2 to the 6. All right. Well, 1/2 squared is just 1/4, right? If you want, we can just put it in like this. 8 times 1/2 raised to the 2 is 2. So this one's 2. And then I'll just hit second enter and raise that to the 3. And I get 1. So the next one's 1. Since we're repeatedly multiplying by half every time what the numbers are getting smaller, so it's always going to be half. So this next one should be a half. That's right, because half of 1 is a half, so that's 0.5. And then the next one's going to be half of that, which is 0.25. And the next one will be half of that, which is 0.065, I think. No, it isn't. It's 0.125. All right, so let's add those up. 2 plus 1 plus 0.5 plus 0.25 plus 0.125. 3.875. All right, we can turn that into a fraction. The way you do that is you, well, on the calculator you do math. First choice is fraction, choose it, and then just hit enter. Gives you improper fraction, which is perfectly fine. So that's 31/8. Both these answers are correct. I prefer the fractions, especially if you have to round, because I'd rather have an exact answer than an approximate answer. These are both exact answers because I did not round here. But if you were to get like 0.33333 as an answer and it just keeps going, then it's better to write your answer as 1/3, which is what gives you 0.33, than it is to just put 0.33 and round it. Okay, I want to do one more, and that'll be it. So number 6. Make this one super easy to end with. How about that? So we'll do 1 to 5 of 10. What does that mean? Well, the first number is 10. And the second number is, guess what? It's 10. And the third number is 10 as well. So is the fourth. So is the fifth. So there's nothing to do. There is no exponent like there is up here that affects the outcome. No matter what, the term is always 10. So that's just 1, 2, 3, 4, 5. So there's 50. That's it. All right. Thanks for watching.